everyone. So we are from Group 9 here. We're going to present about the Experiment 5, Measurement of Jet Forces. Before that, let me introduce our group members. Me, Redan Chandra, alongside with Pavitra and Nurul Nafisha and Siti Norantasha. So these are the contents of our report. First, I will start off with summary. So the jet effect is a system that makes it possible to compute the force generated by a water jet that affects a flat plate of hemispherical surface. The main aim of this experiment is to measure the force exerted by a fluid jet impinging upon a flat plate or hemispherical surface and to compare the results with the theoretical values. The approach for this experiment is to adjust the control valve to load some weight onto the platform of the water jet to measure the effect at varying pressures at a certain rate. Water jet from a small opening with a high velocity when exerted on the surface of plate will produce force that gives power to move a system. The principle of jet impact is the basis for the understanding of liquid flow in turbines. In designing impulse turbines, this concept is used where these turbines is a part of the fluid energy in a nozzle or series of nozzles that amid high-speed stream of fluid is converted into kinetic energy. The jet mounted on the turbine wheel hits the rotating blades, generating the energy needed to move it. Based on the types of aims, vents, and control waves that were used, the result gave a different reading. Two geometries can be grouped into the deflectors used in this experiment. This experiment uses flat and hemispherical disk. In this experiment, estimated power FTH and the percentage of error will be evaluated. Here, the theoretical forces depends on the applied weights and the experimental forces depends on the vane's flow rate, velocity and structure. From the experiment, the average FTH for the flat plate is 2.374 Newton, while average FTH for hemispherical plate is 4.456 Newton. It is shown that the force exerted on the hemispherical plate is greater than the flat plate. In addition, the average percentage of relative error calculated for the plate is 14.39%, while the average percentage of relative error calculated for hemispherical plate is 10.93%. The percentage of relative error for both flat and hemispherical plates show fluctuation. Next, for the theory part, I pass it to Antasha.
My name is Antasha, so I will present about the theory of this experiment. Okay, so first, we all know that water turbines are widely used throughout the world to generate power. The impact of water generates a torque and on the wheel of the turbine, causing it to rotate and to develop power. As stated in Newton's second law of motion, when impinging on a flat, flat plate or hemispheric surface, the jet hemisphere and the jet of air will create force. This is because of the changes in the velocity of the fluid. And then, for instance, when a velocity of water from jet nozzle with diameter D strikes on a flat plate or a hemispherical surface, the rate of change of momentum m equals to PAV produced at its magnitude is the same with the force exerted on the surface of the flat plate or hemispherical to support the water jet. The F generated by a jet of water when it strikes depends on the shapes of the surface, flat plates or a hemispherical surface. Okay, next. Okay, so the figures below illustrate a jet fluid issued from a diameter nozzle and also flowing vertically upward at velocity. The strike flat plate and, and hemispheric surfaces respectively. The jet is then deflected by the angle of the surface of the flat plate or hemispherical plate and leave the surface with velocity. Okay, so this is the illustration of the jet of fluid strikes a flat plate. The theoretical force generated when the jet of fluid strikes a flat plate is the equation is F equals to PAV squared minus PAV2 squared cos theta equals to 90 plus V2 cos 90 equals to V1 equals to 0. So we can simplify the equation as F equals to PAV squared 1. Okay, next. Okay, so this is the illustration for the strikes for the jet of fluid strikes a hemispherical surface. So for the hemispherical surface, that is the equation, and it can simplify as F equals to 2 PAV squared 1, where F equals to theoretical force exerted for both flat plate and hemispherical surface. A equals to cross-sectional area of nozzle. P equals to water density. Theta equals to angle of water flow after impact on the flat plate or hemispherical surface. Okay, next. Okay, that's all from me. Okay.
Hi, I'm Pavitra. Let me continue with the apparatus used in this experiment. First, weight position, lever mechanism, deflector, tank, water supply, nozzle, water drain, main switch box, flow control valve, volumetric measuring tank, and lastly sliding valve. The figure shows the apparatus set up for jet forces measurement test bench. Next page. Okay, so for the procedure, the first step is the tested deflector, the flat plate, is assembled. The second step, the pointer is set to 0 or 0 notch by adjusting the screw at lever mechanism. When doing so, do not place any weight on the lever mechanism. Third, the main switch and the pump is turned on. The fourth step is the flow control valve is opened slowly and the desired weight is put on the lever mechanism. The flow control valve is adjusted until the pointer at lever mechanism is at 0 notch. Next page. The fifth step is the sliding valve is closed. The flow rate of water Q is recorded by recording the time taken required to fill up 3 liters volume of water in volumetric measuring tank. Step 6 is the sliding valve is repeated. Repeat step 4 and 5 by decreasing the desired weight on the lever mechanism until the flow control valve is at minimum opening. Step 7. The main switch and the pump is turned on. The sliding valve is opened and the flow control valve is closed. And the last step is the weight on the lever mechanism is removed and changed the deflector plate to hemispherical surface. Step 2 to 7 is repeated. Next. Next, I pass to Nafisha.
Okay, I am Nafisha. I'm going to proceed with the data and result for this experiment. So, these two tables shows the data and result obtained for flat and hemispherical plates respectively. The data um, the data given is the measured force in unit Newton for both plates, the volume of water collected, which is 2 liters, and the time in seconds. From this data, we are able to calculate the flow rate Q, the velocity, the theoretical force, and also the percentage of relative error between the measured and theoretical force. Next slide. This is the calculation to obtain the values. As we know, the density of water is 100 kg per meter cubic, and we are given the diameter of nozzle, which is 10 millimeter. So here, I take measured force of 1 Newton as an example. To calculate the value of Q, we divide the volume with the time, and we'll get the Q in liter per second. By obtaining the value of Q, we can calculate the value of velocity using the formula Q equals to AV. To calculate the theoretical force for flat plate, we use the formula F equals to rho AV squared, while for hemispherical plate, we use formula F equals to 2 rho AV squared. So then we can calculate the percentage of relative error by using formula measured force minus theoretical force divided by theoretical force times 100%. So these calculations are repeated for each value of measured force for both flat and hemispherical plates. Next slide. Okay, so next I will continue with the discussion. So in order to find the graph of log measured force versus log velocity, we need to find the value of log V and log F measured first for both plates as shown in the tables. So next slide. Okay, so this is the graph of log F measured versus log V obtained from the experiment. As we can see in the slide, we obtained the linear graph for both flat and hemispherical plates. The orange line is the hemispherical plate, while the blue line is the flat plate. So each linear graph produces an equation as stated in the slide. Next slide. So next, we compare the slope of the graph for both plates and compare with the theoretical value. We plotted another graph, which is the graph of log f theoretical versus log v. For the log f measured versus log v graph, we obtain the value of m, which is the slope for flat plate, equals to 1.7008, while 1.8415 for hemispherical plate. So for graph log f theoretical versus log v, value of m for flat plate is 2, while hemispherical plate is 2.0001. So uh, the measured value of both plates is slightly different, with the theoretical value due to some errors occurred when the experiment is conducted. Besides, there is difference in the force impact towards the surface of the plates due to the different angle of water impaction, causing the values of the slope different between the measured and theoretical values. Next slide. Okay, so next, we estimate the y-intercept ratio of hemispherical plate to flat plate and compare with the theoretical value. So by logging both sides of equation 2 and 4, we are able to obtain the equation of log f theoretical equals to 2 log v plus log rho a for flat plate, and log f theoretical equals to 2 log v plus log 2 rho a for hemispherical plate. So this equation is similar to equation of line y equals to mx plus c, where the y-intercept for the flat plate is equal to log rho a, while y-intercept spherical plate is equal to log 2 rho a. To calculate the theoretical ratio, we divide log 2 rho a with log rho a, and we got 0.7276. For measured or experimental ratio, we divide the y-intercept obtained from the graph and we get 0.7583. So the theoretical ratio of y-intercept ratio is slightly different with y-intercept ratio obtained from the graph. The slight difference occurred due to some errors occurred when conducting the experiment. Besides, there will be some losses in pipe while ejecting the water to the plate, which will then change the values of measured force and velocity a bit. Next slide. So next, we compare the force exerted on both plates by calculating the average of theoretical force obtained. The average for flat plate is 2.374 Newton, while 4.456 Newton for hemispherical plate. Based on the calculated average of F theoretical, it is shown that the force exerted on the hemispherical surface is greater than the flat plate. This is because the change in momentum of the hemispherical surface water jet is higher than the flat plate. Higher energy is produced when the water jet from the nozzle hits the curved surface of the hemispherical surface due to the 180-degree angle of the surface that allows the water to reverse its direction. So the surface of the flat plate has a 90-degree angle where the water can only flow in one direction. So as the water jet reaches the surface of the flat plate, lower energy is released. Uh, as we can see from both equations, it can be clearly shown that the force exerted on the hemispherical plate is 2 times greater than the force exerted on the surface, the flat surface. Next slide. So the average percentage error for flat plate is 14.39%, while hemispherical plate is 10.93%. The percentage of relative error for flat plate ranging from 1.478% to 25.62%. Meanwhile, the percentage of relative error for hemispherical plate ranging from 2.141% to 25%. The percentage of relative error for the percentage of relative error obtained from this experiment are inconsistent for both flat and hemispherical plate. In addition, we can see that the percentage of relative error for flat plate is higher than hemispherical plate. Since the equations to calculate F theoretical depends on the angle of the plate that will impact the velocity of the fluid jet, the result will be inconsistent through the experiment due to some errors. So one of the errors is the plate may not be in perfect shaping, and thus the angle may be slightly different from the original. Other than that, the spring coil that is used in this experiment must be in correct position, which is in straight, standing and perfect position to avoid inaccuracy of the velocity of water. So that's all for me. I will pass to the next presenter.
So next, we will briefly discuss on factors contributing to errors or inaccuracy in experimental data and the possible recommendations to improve the existing results. So the first will be the pump velocity that not precise and the existence of air bubble in the pump might occur. The air bubbles inside the pump may cause the result to become inaccurate. Next, the control valve may not be open fully. Hence, this may also cause the velocity of the water obtained less than the actual value and causes the reading to be slightly off. Third one will be the parallax error. The parallax error may also occur like observers' eyes are not perpendicular to the water level when taking the reading of for 2 liters of water in water tank. So the time taken for collecting of 2 liters of water in the tank may not be accurate and affect the experimental result. Next one, the spring used also may lose its elasticity and this can cause systematic error and all the reading will be wrong. Last but not the least, errors may occur in calculating due to the uncertainty in measurement as well as the mistakes made during the calculating the results. However, these errors can be overcome to improve the accuracy of experimental data. First, opening the valve to remove the air bubbles that may present in the pump before the experiment starts. Next, by making sure the control valve is fully open when conducting the experiment, hence the precise reading can be obtained. In addition, parallax error can be prevented by ensuring the observer's eye are on the meniscus of the water when collecting the data. Besides that, check the spring before conducting the experiment and replace the spring if necessary. Moreover, repeat the experiment at least 3 times for each readings to get the true value by finding its average. Last but not the least, plates that have a perfect shape are used to increase the accuracy of forces exerted on the plate and thus giving a more reliable data. For the next part, I leave it to the next presenter.
Next, next we have to suggest two application of the jet impact industry. So one of the application of jet impact is used to generate electricity. Impact of the jet is used to rotate the turbine, namely the Pelton wheel in the generator. A tangential force is applied by the water jet to the wheel. The tangential forces of water jet increase the mechanical energy of the Pelton wheel by generating the moment of torque on the wheel to its optimum value. And then the rotational energy of the wheel is then converted into electrical energy. Okay, so next. Okay, the second one is water jet cutter. Water jet cutter is another application of water jet. By combining the high pressure and the high velocity of water jet with an abrasive substance, water jet cutter is capable of slicing metal or other materials. And then water jet cutting is similar to natural water erosion, but it happens with extremely accelerated and concentrated water. Okay, next.
In conclusion, this experiment is conducted to measure the force exerted by the fluid jet on different types of plate, which is the flat plate and hemispherical surface. The average experimental value for of force of 2.2 Newton for flat plate and 4.4 Newton for hemispherical plate are compared to the theoretical value of 2.374 Newton for flat plate and 4.456 Newton for hemispherical plate by using the formula and results in the experiment. Due to some errors occurred during this experiment, the experimental data deviated greatly from the theoretical value. From this experiment, we can conclude that the force exerted on the flat plate is smaller than the hemispherical plate. Thus, the objective of this experiment are achieved. So that's all from us. Thank you.